Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following trigonometry in triangles. We have a hot air balloon, H, is directly above point B on the ground. Two ropes are used to keep the hot air balloon in position. The ropes are held by two people on the ground at point C and point D. BCD are in the same horizontal plane and the angle of elevation from C to H is x as shown, and angle CDB equals to 2x. CBD is equal to 90 degrees minus x, and the distance between C and D is k meters. The first part of the question says, show that CB equals 2k sine x. If you look at the diagram given, to find CB, I'm going to use the triangle BCD as shown. And if I have a quick sketch of that, I have B has been given as 90 degrees minus x. I have the angle at D, 2x. And then I have C and the distance between C and D, that's k. So starting with the first part of the question, to find CB, I'm going to use my sine rule. So using my sine rule, which states that the ratio of the side CB divided by sine of the angle facing CB, that's D in this case, is equal to the ratio of the side CD divided by the sine of the angle facing CD. I'm going to put that in brackets, 90 degrees minus x, that equal. So therefore, putting in my values, CB, which is the missing side, divided by sine D, that sine of 2x, is equal to CD, I have that as k, divided by sine of 90 minus x. I'm going to use my cofunction. Or, to make it easy for you to understand, I'm going to change that to sine of b. And then I'm going to fit in the value in the second statement. That's sine of 90 degrees minus x. Okay. Now that I have that, the next step, I'm going to do what I call cross multiplication. That is, the denominator on one side multiplies the numerator on the other side, as shown. Therefore, that will convert that to a linear equation, which states that CB times the sine, I can put that without the bracket, times the sine of 90 degrees minus x is equal to k times sine of 2x. And therefore, to find CB, I'm going to divide both sides by sine of 90 minus x. So I have CB equals k sine 2x divided by sine of 90 degrees minus x. So therefore, using my identities here, I'm going to change my sine to x using the identity for double angles. And then I'm going to change my sine of 90 minus x using my cofunction. And that will give us k times 2 sine x cos x divided by, using my cofunction, sine of 90 minus x will be cos of x. And therefore, I have similar factors at the top and at the bottom. That goes out. Therefore, my CB will be equal to k times 2, that's 2k sine of x. And if you check what I have, that's equal to the first answer. That's show that CB equals to k sine x. Let's look at the second question. The second part of the question states that we are to show that the length of rope HC is 2k tan x. So the triangle I'm going to use in this case will be the triangle BCH as shown, and I'm going to draw a quick sketch. It's a right angle triangle. The right angle is at B. I've been able to calculate the distance CB from the first part of the question. That's 2k sine of x. And then I have the hot air balloon H as shown. I have the angle at C, that is x. To show that HC equals 2k tan x, I'm going to use my trig ratios because that's my right angle triangle. Starting with the labeling of the sides, the side facing the reference angle will be my opposite. And then the side facing my right angle, that's my hypotenuse, which is always the longest side. And the last side is my adjacent. So in order to find HC from the question, what I need is HC and the side given, that's CB. That's my hypotenuse and adjacent. And if I look at my trig ratio acronym, that's my SOHCAHTOA. The question is, which of the trig ratio uses hypotenuse and adjacent? And that will be my cosine, which is cos. So therefore, cos of the reference angle, that's cos C, is equal to adjacent over my hypotenuse. The cos of x equals my adjacent in this case, that's 2k sine x, divided by my hypotenuse, that is my HC. I have that is over 1, so I'm going to do the same by cross multiplying. If I cross multiply, I have HC cosine of x equals 2k sine x times 1, which remains the same. So therefore, my HC, I'm going to divide both sides by cos x, will be equal to 2k sine x divided by cos of x. Now note that for my identity, tan theta is equal to sine theta over cos theta. So I'm using my identity to change sine x over cos x here. So therefore, my HC is equal to 2k tan of x. So I've been able to show that the distance HC, that's the length of the rope, is equal to 2k tan x. Let's look at the last part of the question, which says if k equals 40 meters, x equals 23 degrees, and HD equals 31.8 meters, calculate theta, the angle between the two ropes. So because I want to calculate the angles between the two ropes, I'm going to use the triangle HCD highlighted. And if I draw a quick sketch of that triangle, what I'm going to have is, I have that as theta, which is my H, and then I have C, I have my D. The distance CH from the previous question is, I have HC equals 2k tan x. We've been given k to be equal to 40 meters. So therefore, rewriting that will give me 2 times 40 tan x. X also has been given as 23 degrees. So I'm going to replace that. That's tan of 23 degrees. Therefore, my HC is equal to 33.96 to 2 decimal places, and that is in meters. So therefore, I have HC, that's 33.96 meters. CD is K, which is 40 meters. That's given from the question. And then HD is also given from the question. That's 31.8. So I have HD 31.8 in meters. So therefore, to calculate angle theta, I'm going to start with using my cos rule, which states that the side CD squared, that's the side facing my reference angle, equals to the sum of the square of the sum of the other two sides, so that's HC squared plus HD squared minus 2 times HC times HD. My dot means multiplication. Cos of the angle subtended by the two sides, that's cos theta. Putting in my values, I have 40 squared equals HC squared, that's 33.96 squared plus HD 31.8 squared minus 2 times 33.96 times 31.8 times cos of theta. If I resolve this, I have that as 1,600 equals 2164.52.6. That's what I have on my left hand side, so that's minus 2,159.856 cos of theta. I'm going to make theta a subject of formula, so therefore my cos theta is equal to, I have 2,164.5216 minus 1,600 divided by 2,159.856. I have my cos theta to be 0. If you punch that in on your calculator, 2614. And in order to find theta, theta will be equal to the arc cos of 0.2614. Arc cos is the second function of your cosine button. So therefore, theta will be equal to 74.85 degrees. Thanks for watching. Bye.